So now in this video we're going to first look at some things that we covered before. We have a trim pot here which we can get a variable voltage. We can turn it all the way to the positive supply there for 4 volts or all the way down to the negative supply for 0 volts. I have it halfway approximately so that we have about half the voltage there, 2 volts out of 4 for the most part. Now I also have a Zener diode here. This is a 3.6 volt Zener diode, but these lower Zener diodes, their voltage drifts quite a bit when it comes to how much current is flowing through it. So lower current, it's going to have a lower voltage by quite a bit. I think once you get to 6 volts, it's really accurate, even as current changes a bit. But in any case, we're going to bump this up to 12 volts to do our comparison right here. And ultimately, we're going to combine the Zener diode with the trim pot, because as we'll see, the Zener diode, it actually did drift its voltage a bit. There you can see it went up about 0.8 volts or whatever, but we went up 8 volts more on the power supply. And with the trim pot, again, we have the 12 volts at the rail right there, and the output is 6 volts, so quite a difference. We went from 2 volts to 6 volts. So I want to make it so that even as the supply voltage goes up, the trim pot voltage stays pretty steady in comparison of 4 and 12 volts. So we're going to plug it in right here, and I'm going to try to leave room on both sides. And we're going to take the 1000 ohm resistor right here and put it up to the top of the resistive element. The Zener diode, so remember Zener diodes, this is a 3.6 volt Zener diode. That's the cathode. The black stripe there goes to the positive side. The anode goes to the negative side. Reverse bias, the opposite direction that you got most diodes for when you want them to conduct. This is generally the direction where it blocks a lot of voltage, but Zener diodes have a Zener voltage where it will conduct safely. Most diodes you want to avoid putting them in reverse bias and having them conduct. So there you can see it right there. Now the reason why we are doing this is because now again we still have across the Zener voltage, since it's 12 volts, about 3.8 volts as you can see there. And at the output now of the trim pot, we have a little less than 2 volts right there, 1.9. So it'd be better if this Zener diode didn't drift as much, but we're going to lower the voltage here to 4 volts, and we'll still be, you know, somewhat close to 1.8 volts out. And it's going to drop a bit though, as we saw before. But there you can see about 1.4. So the voltage didn't change a whole lot, even though the supply voltage changed 8 volts. But there you can see it drifted a little bit below 3 volts because it's a lower value Zener. And here is the diagram. So really I wanted to use this circuit fragment in a bigger circuit, but I don't think it's going to work out. And one of the issues was that the voltage across the trim pot with the 3.6 volt Zener diode went all the way up to about 3.8 volts and then all the way down to about 3 volts. That caused the problem. I needed a little more accurate voltage. But that's a big reason why I made this video, just to show that weakness of a low voltage Zener diode, so that hopefully you don't run into that problem if you design a circuit later on. You're aware of that and you find a different solution. But in any case, we got current going through the 1000 ohm resistor, and then current going through the Zener diode to set that voltage across the trim pot. And so we have a relatively fixed voltage. So if we set the trim pot all the way up, we should have about 3.6 volts out. We go all the way down, we should have about 0 volts. And if we go halfway, we should have about 1.8 volts, approximately, right there. But again, we had that drift. So just something to be aware. Cathode goes towards the more positive side, anode towards the more negative side, because this is one of the rare diodes that can conduct while reverse bias. And we can take advantage of that voltage. Also, always got to remember that when it comes to trim pots, they generally cannot power things. Maybe if they're low enough value and the other thing doesn't need much current. But for the most part, they can't really provide current. They provide a signal voltage, and something else responds to that. some other circuitry that just looks at that voltage and does something with it. So in any case, that's it for this video. Hope you enjoyed. Also, actually, the Zener diode that I got it out of this, I bought a whole bunch of different Zener diodes, and they wrote the value on there. One of the baggies, though, they put the wrong value in there. So I bought them from China. They were really cheap. But that's 3V6. They put the V in place of the decimal point because you might not see a decimal point, and you might think it's 36 V for volts. So they take the V and put it in place of the decimal point. 3V6, 3.6. Also, if you have a loop or something where you can really look at the small writing, it says 3V6 right on them. So that's another way you can tell. But this camera won't zoom in that much. So hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. I'll see you in the next video.